Graphing secant and cosecant has a number of similarities to graphing tangent and cotangent. The first important similarity to look for is that secant and cosecant will have asymptotes, vertical asymptotes to be specific, just as tangent and cotangent did. So our first goal is to identify where are these vertical asymptotes. To do that, we want to think about secant as being 1 over cosine x and cosecant as being 1 over sine of x. When I look to graph y equals secant of x, the asymptotes will occur whenever I'm dividing by 0. So, when will cosine of x be equal to 0? We've seen this before when we looked at the unit circle. We know that the answer for this should be that when it happens when x is pi over 2, 3 pi over 2, negative pi over 2, or any other multiple of pi over 2. So let's plot those on our graph on the x-axis. Negative pi over 2, pi over 2, 3 pi over 2, and a vertical asymptote should occur at each one of these values. Now, to decide what our graph looks like, I want to look at the unit circle. And I'm going to start at an angle of 0. Here, we have a cosine value of 1, so we have a secant value of 1 divided by 1, or 1. However, if I move in either direction, the cosine value gets smaller. 1 divided by a number smaller than 1 will grow. And it will actually grow to infinity as the cosine value gets closer and closer to 0. Something similar happens on the opposite side of the unit circle, where we have a cosine value of negative 1. Here we're looking from pi over 2 to 3 pi over 2. At an angle of pi, we have a cosine value of negative 1, which means we have a secant value of 1 divided by negative 1, or negative 1. And if you go in either direction, we're going to take 1 and divide it by a negative number. So we see this pattern. And this will repeat on end in either direction, here and here. And it is important to notice that this pattern will repeat not for each u, but for the entirety of 2u's, which means that the period is 2 pi. A very similar trend takes place when we look at cosecant, but instead we are asking ourselves, when does sine equal 0? Here it's going to happen when x is equal to 0, pi, 2 pi, negative pi, or any other multiples of pi. So when we graph this, we want to have an asymptote at 0, pi, 2 pi, negative pi. And we can apply the same logic that we used earlier with the unit circle, but this time we want to be thinking about y values, or sine values. So, here, I don't want to consider what happens at an angle of 0 or pi, because there are no values there. Those are asymptotes. Instead, I'm going to consider what happens at pi over 2. On our unit circle, at pi over 2, we have a sine value of 1, which means we have a cosecant value of 1. Here, at 3 pi over 2, we have a sine value of negative 1. So 1 divided by negative 1 will end up on the bottom side. And we'll end up with our same u's when we get from dividing 1 by small positive or negative numbers. And that is our graph for cosecant x. And there you have graphing either one.